Currently, there is a lot of talk around arc flash safety in all industries, including hospitals. Because of the NFPA 70E, arc flash hazards have become a focus of electrical safety programs for contractors and maintenance personnel. While arc flash is extremely important, we cannot forget about the danger and risks associated with shock hazards.
So when you think about electrical safety, there are basically three different types of hazards. You have your shock, arc flash, and arc blast. I always lump arc flash and arc blast into one topic. So you have shock and arc flash. Both of those are just as critical as the other. I mean, they'll both kill you. And as designers and as electrical contractors, we've got to be thinking about the individual who's going to be working on this equipment. We want to prevent them from accidentally coming in contact with something that's energized, which will help prevent shock and also help reduce the likelihood of having an arc flash event.
You have likely attended OSHA electrical safety training, which highlights the key points of shock hazards. OSHA has strict guidelines in place for not only the designs of electrical systems, but also safety-related work practices. This training applies in hospitals, but you should give special consideration to shock hazards associated with multiple sources of power, including sources from the utility, generators, or both. In addition, you also have to be aware of DC sources like batteries and UPSs to protect you from shock hazard.
A hospital is usually fed from at least two sources of power with generator backup. A lot of them have three sources of power coming in. So they are very conscious of losing power. They're off at different grids, different loops, so that they have redundancy, that they're sure if they lose one, they have at least one for backup. The electronic, the UPS, it is something for their data centers in a hospital. And the data centers with UPS backup, generator backup, they do not want to lose those systems. We talk about life safety on that point. You're going to the other end of it. That's all their billing. Patient information is all stored through that database. And that is something else that you do not want to shut down in a hospital. It's very important to them.
Hot work still does exist in hospitals, especially depending on the system that you're working on. Some systems, such as UPS systems, can be very, very difficult to shut down. Everything can be shut down if it needs to be shut down, but it could be a situation of planning for something that's 6 months in advance. In order to clear out the patients that are needed from an entire wing of a hospital, if you need to work on a UPS system that actually needs to be shut down. Arc flash equipment is very important for systems that cannot be shut down. You need to understand what type of a system it is, how much power that system can possibly generate, and the type of protection that you need to have on site if something needs to be worked on live.
What are the key things for you to know about arc flash hazards as it relates to you in hospital applications? The release of energy caused by an arc flash can reach temperatures that are greater than 20 to 30,000 degrees Fahrenheit. This release of energy is dangerous in many ways, including the extreme heat, flying molten copper that gets vaporized at these temperatures, the pressure from the shock wave, and the high levels of light from the radiation wave. The arc flash energy that would arrive on bare skin or on the surfaces of any garments you are wearing is called incident energy and is expressed in calories per centimeter squared. A calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. 1 calorie of heat is equivalent to holding a match under your finger 1 inch away for 1 second. It takes 1.2 calories per centimeter squared for 1 second impinged upon human skin to reach the threshold between a first-degree burn and a second-degree burn, which is often called just curable burn. Now, imagine an arc flash with an incident energy rating of 50 calories per centimeter squared, which is very possible in a medium to large hospital. The temperature from that arc could reach 27,000 degrees Fahrenheit, or close to 3 times the surface of the sun temperature. With that amount of energy, the vaporized copper would be traveling at speeds greater than 700 miles per hour. To imagine the amount of pressure created, picture a pea-sized piece of copper vaporizing to a point that it would fill a railroad car. This blast has been compared to a stick of dynamite going off, which helps to explain the severity of it. In order to protect personnel working on or around electrical equipment, information is gathered and an arc flash study is performed to determine incident energy levels.
Arc flash is an important topic for the electrical worker. It's life and death. And you have to regardless, even if you say you're going to establish an electrically safe work condition, you need to dress to be able to know whether or not you've established an electrically safe work condition. So arc flash incident energy is all about the electrical worker and going home safely.
Arc flash is, from our standpoint, we do look at the arc flash stickers if we have to throw a breaker or we have to turn a breaker on, so we know what calorie suit that we have to wear in order to perform that task. What I will say about arc flash studies, even though the industry is going to have in a direction to have that on every piece of equipment, things change so fast and construction gets updated and changed. Those arc flash stickers are not always the most updated.
Arc flash labels indicating the incident energy level and the arc flash boundary are affixed on safety switches, panel boards, switchboards, switch gear, MCCs, and other pieces of electrical equipment.
As a field electrician, the primary thing that we look for off of the arc flash label is the boundary area to make sure that everybody else can be kept, and to make sure that we set up the right sized perimeter to keep anybody that should and that does not absolutely have to be in that vicinity out.
As part of NFPA 70E, site operators and maintenance personnel should be trained on how to read arc flash labels and understand the proper personal protective equipment, or PPE, required when working inside the arc flash boundary.
If I was the electrical worker, wanting to know what codes and standards should I focus on, the first level a line of defense is from an electrical worker's perspective, from a contractor's perspective, is NFPA 70E. It's critical. It's not enforced by anybody outside of OSHA referencing it, but it's critical to electrical safety. And 70E pulls together the aspects of maintenance to make sure you install the products correctly per the NEC. So a focus on safety will go a long way from a reliability and from the electrical worker or electrical contractor's perspective.
Consultants and engineering service providers offer arc flash hazard analysis and training, as well as advice on how to implement solutions that reduce arc flash levels.
So another critical aspect from a design perspective, put things in place that helps the electrical worker establish an electrically safe work condition. It could be adding a disconnect in front of a piece of equipment. It could be buying a transformer that has an integrated overcurrent device, either on the primary or secondary, so that they can turn that off. It's accessible and close. That is critical for electrical safety.
Some of the most misunderstood things related to arc flash are working distance, incident energy, arc flash boundary, and PPE requirements. A good understanding of the arc flash label helps to clarify most of these points. Looking at the label, the working distance is defined as the distance from your face or torso to the energized conductors. This can be 18 inches, 24 inches, or 36 inches, depending on the voltage level. This is roughly an extended arm's length. Incident energy is the energy that would arrive on bare skin or on the surface of any garment you are wearing during an arc flash event, expressed in calories per centimeter squared. The arc flash boundary is the distance from the energized equipment to the point at which the incident energy drops below 1.2 calories per centimeter squared. PPE requirements indicate the type of clothing required to protect a worker against the incident energy at the working distance as indicated on the label. The label may also indicate a secondary incident energy level and arc flash boundary if the arc flash reduction means are installed. The most likely time for an arc flash to occur is during interaction with electrical equipment. This can include racking in or out breakers, installing a bucket in MCC, or operating a switch or breaker, for example. An arc flash hazard analysis or study provides insight into the safety of a hospital's electrical system. Through training and the implementation of suitable solutions, the probability of an arc flash event can be reduced, in some cases without investment in equipment or further studies.
My goal from a designer's perspective, from an influencer, from a codes and standards perspective, is to do everything I can to help get the electrical worker into daily wear. We don't want to see people walking around in 40 cal outfits and moon outfits. It just creates, that's just ungood. You want to get the electrical worker in something comfortable, and to do that, you need to make sure you analyze the power distribution system. You've got an accurate one-line diagram. You do your short circuit study, you do your coordination study, you establish your arc flash study, and then put in place the design things you need to do to get that worker into a lighter PPE.
The different calorie suits that you might have to wear, whether it's a 42 calorie suit or even a lower suit where you only need to wear just a face shield and a fire retardant jacket, compared to a 42 calorie where you have to wear a full suit head to toe, including a full hood. Personally, as a field electrician, I've always found it easier to work in a lower calorie suit. The higher the calorie suit, the more protection it gives you, but at the same time, that more protection also means you have more layers on top of you that you're not used to working in.
The PPE that you wear to protect yourself depends on the incident energy and voltage level. These two arc flash suits are examples of an 8 calorie and 40 calorie system. There are many different arc flash solutions. Time and distance are typically the variables that we focus on to eliminate or reduce the risk of arc flash injuries or equipment damage. Of course, de-energizing your equipment is always the safest bet, but we know that isn't always possible, especially when working in healthcare environments.
For arc flash solutions to try to limit how much time we would need to spend in the suit, there are newer breakers out there. There are newer methods, depending on how new the equipment is in the hospital. Many hospitals still don't have the newest, latest, and greatest protections installed. So it is important to look at every element in the system and see what the best solution is going to be for you to maintain a safe work environment, but still be able to get your work done in the most efficient manner.
There are essentially two main categories of arc flash solutions. One, the solutions that protect people and equipment by reducing the arc flash energy, and two, solutions that put people out of harm's way in case an arc flash occurs. Here are some examples that we think you, as a contractor in a healthcare environment, might want to know about. Arc quenching switchgear is revolutionizing the industry by creating a solution that not only protects your gear, but anyone standing near your switchgear during an arc flash event. Basically, arc quenching switchgear uses a system of light sensors, current sensors, and this device to create a parallel arc during an uncontrolled arc in the switchgear to provide an alternate and controlled path for fault current until an upstream device can clear the fault. During this scenario, your people and equipment are protected because the arc quenching switchgear reacts so fast and responds before the dangerous pressure wave can build up. Think of this device as an arc flash airbag for your electrical system. Arc Flash Reduction Maintenance System, or ARMS, is available on low voltage power circuit breakers and many of our molded case circuit breakers. This system uses patented technology to reduce arc fault clearing time, lowering the available arc flash energy at the connected downstream equipment like motor control centers, switchboards, panel boards, and other equipment. The system may be activated at the breaker or from a remote location. The result is a reduction of the incident energy during equipment maintenance, allowing for improved personnel safety while eliminating the need for higher levels of costly PPE. With a lock applied at the breaker during your LOTO procedure, you can ensure that you are protected while working on downstream equipment. For most power systems, the highest level of arc flash energy on low voltage switchgear is on the source or the line side of the main circuit breaker. One great option to reduce this level is the Arc Fault Current Limiter, or AFL. For this demonstration, we have replaced the typical medium voltage primary fuses protecting this transformer with a medium voltage vacuum circuit breaker and we installed current transformers, or CTs, on the secondary of the transformer and added another protective relay. Since the breaker has two protective devices that can trip it, one is set as it normally would to overcome the 12 times inrush current for the transformer, and the other is connected to the transformer's secondary CTs. Using an arm setting, it will trip without delay during a fault condition. This arc flash label indicates that the arc flash energy at the line side of this breaker is normally 68 calories. The AFL solution significantly reduces the arc flash energy to 1.4 calories during maintenance conditions. Basically, with the same type of concept, we can install that primary breaker inside a liquid-filled transformer. For liquid-filled transformers, you might want to consider a vacuum fault interrupter, or VFI option like this one, which allows you to have the primary protective device, a vacuum breaker, installed in the tank along with the visible means of disconnect. In addition, you could also put the oil sample valve on the side like this transformer instead of behind the door. This allows you to do oil testing without opening the transformer doors on a pad-mounted transformer like this one. Now, switching gears a little bit, let's talk about arc flash solutions that keep people out of harm's way. The first solution is called arc-resistant switchgear. In general, arc-resistant equipment contains and redirects arc energy away from personnel out of the top of the equipment. The most common is called Type 2B, meaning you could walk all the way around a section of equipment, and if an arc flash occurred inside, you wouldn't be hurt because the arc flash energy would be exhausted or dissipated out the top, and in some cases through a plenum outside the room or area where you're working. Here's an example of our 15 kV class medium voltage switchgear, and here's our new XGIS 38 kV switchgear. Notice the heavy-duty construction and additional doors on the relay sections to protect you while working on the control equipment and relays. The next solution focuses on remote operation and racking of circuit breakers. This includes integrated racking that can be remotely operated with a pennant like this one or through an HMI. It also includes these MRR1000 and RPR2 racking devices that can be installed and then controlled from a safe distance away, as shown here. Finally, for motor control centers, this FlashGuard MCC can be withdrawn from the live bus with the door closed and installed with the door closed, even with this remote operator to keep personnel out of harm's way in the event of an arc flash. As a contractor working on equipment in a healthcare facility, check to see if these remote racking devices or systems are available before you plan your work. More and more, we are asked by our customers to provide equipment that can be remotely operated or controlled with an HMI to reduce exposure during arc flash events. This Power Expert dashboard is a perfect solution to not only see what the arc flash levels are, but you can monitor power flow and control the equipment. As an example, hospitals can remotely rack medium voltage breakers, operate the main time main on low voltage switchgear, or engage arms on multi-case circuit breakers with a dashboard. The dashboard is also a convenient place to store all of your one-line diagrams, riser diagrams, and maintenance records for the hospital equipment. This may help you quickly find information and solve problems during contingency situations.
So as an electrical worker, if you're troubleshooting a problem, you need to know where to look, right? So the one-line diagram is critical because you need to know what circuits, and you need to, if you're looking at a piece of equipment and it says it feeds a heater, it better feed a heater, because if the heater's the problem, and then you know what circuit you're working on. So if your labeling is off, then you don't know, you're flying by the seat of your pants. You've got to be able to hone in and be critical to be able to solve the problem quickly.
Other arc flash safety solutions to keep you out of harm's way include IR windows that allow you to look for potential issues inside your switchgear, switchboards, or other equipment like busway. Double door safety switches allow you to install fuses and make connections on the load side of this switch without being exposed to the line side or energized connections. This greatly reduces risk, as you must consider the arc flash level on the source side even if the switch is in the open position with the door open on a standard safety switch. Anything that compartmentalizes electrical components generally helps with arc flash. Line isolation switches create an external connection point for enclosed control cabinets, allowing you to lock out a switch and completely isolate the inside of the control cabinet like a VFD. In most applications, the incoming breaker or connection point inside one of these control cabinets has line voltage and again must be considered as live for arc flash considerations. Electrical maintenance and testing in a healthcare facility is crucial to ensuring equipment is going to perform properly and make the overall electrical system safe and reliable. Without proper maintenance, there are a lot of unwanted situations that might occur. For example, a generator doesn't start, transfer switches can't transfer power during an emergency, or even a circuit breaker doesn't trip during a fault.
You know, healthcare environments are all about reliability. And reliability is not something that you just install. You have to make sure that you maintain your power distribution system, just like you maintain your car or your vehicles. 70B, NFPA 70B, NFPA 99, maintenance is getting a much better focus these days. 70B is moving to a standard, to a USHALE document. That's critical to improving safety and reliability in any power distribution system, especially the healthcare world.
So a new requirement for the 2021 version of NFPA 99 is the requirement for an ongoing electrical preventive maintenance program. This sets maximum time intervals for inspection, testing, and maintenance of the critical systems, critical components within the essential electrical system.
If a generator doesn't start or is unable to provide power to the essential electrical system when it is called upon, it can be life-threatening to patients that rely on critical equipment. If a circuit breaker doesn't trip during a fault, that can be extremely dangerous for both personnel as well as the equipment. When a fault occurs on a system, we rely on a protective device such as a circuit breaker or fuse to clear the fault and no longer feed unwanted energy to the already bad situation.
A customer rushing me to get the power back on, and we had a thermomagnetic breaker tripped, and it also took out the main breaker as well, which was a 2400 amp switch, and they wanted me to just hurry up and throw it back on. And when I asked, what work was being done in the building, we have to figure out why the breaker tripped to begin with. They kept telling me to hurry up and get the breaker back on. And then finally I asked again, and they told me that somebody was working on the air conditioning unit on the roof, and here the guy shorted out line to line on the air conditioning breaker, which tripped the thermomagnetic breaker, which also tripped the main breaker. Now, if I had just thrown that breaker back on, there's a possibility the guy could have still been in there, and I could have did more damage to him and to the equipment. So you have to find the time to take your time and figure out what's actually going on and not just rushing into it.
If preventative maintenance and testing is not done or not done properly on circuit breakers, they may not trip when called upon. If a circuit breaker doesn't trip, or even just doesn't trip in the time that it is supposed to, the arc flash incident energy level could increase significantly. As a contractor, this is very important because you would have used that arc flash incident energy level on the arc flash label to decide on PPE. When performing maintenance at a hospital, the scope of work is generally set before arrival, but that is not the case when troubleshooting. As a contractor, you should recognize that the task of troubleshooting an electrical issue in a hospital can take much more time than it would in a typical commercial building. This is due to the complexity of the system as well as the protocols around critical care and infection control.
Service people always need to plan and have a cautious attitude in a hospital. This is where the specific serviceman that goes into the hospital is always very important, because they need to understand the differences between that hospital and a commercial environment whenever they are creating their solutions.
It's not like working at a storefront. When you're working in the hospital, people's lives are dependent upon those systems. So it's something that you have to take seriously, and there's no substitute for experience. And unfortunately, experience comes with time. And the best scenario is to have somebody that is experienced with it that can bring somebody younger up through it. I am where I'm at today because people took the time to teach me. If those people wouldn't have taught me, I wouldn't be where I'm at today.
There are too many different troubleshooting scenarios that could happen in a hospital to mention here, but here are a few things you should consider. Problems on the electrical system can be caused by lots of different things such as loose wires, incorrect connections, cut or damaged insulation, broken connections, overheating of components or equipment, failed motors or pumps, and many more. Another aspect of troubleshooting involves human error. Human error could cause many problems in a hospital, so that is why as a contractor, you need to do everything in your power to avoid problems associated with human error.
Yeah, I mean, it happens all the time. When you rush electrical work in general, bad things can happen. Like this one time, this guy was rushing to get power back on, and he grounded on a meter socket with a wrench. And not only did he take longer because the store had to be without power for several days until we had to, at that point, remove and reinstall. He also had to spend a night in hospital because he temporarily blinded himself. And that's a positive outcome because it could have been a lot worse. So yeah, you always have to take your time and realize what you're working on before you just jump into anything.
Proper planning and execution are key to minimizing human error, but during a troubleshooting situation where you are rushing to get things done, this isn't always the case. Think about the critical equipment in a healthcare facility for both personnel as well as research that could be affected by human error.
Hospitals do a lot of research, so you do. You can't, I guess the best way to put it, you cannot turn something off in the hospital unless you are 100% sure of what you're turning off. That's a rule of thumb that we go by. Unless we know 100% what that circuit is feeding, we do not turn it off. We don't trust the panel schedule. We don't trust writing on the wall. Everything is verified with the circuit tracer that person knows what they're shutting down is indeed what they want shut down.
Because of the critical nature of a hospital, electrical system monitoring is important to be able to see the power system from a centralized location. This allows hospital personnel and you as a contractor to remotely see alarms and potential problems as they occur on the essential electrical system. These systems can also prove beneficial for event analysis. If a full power outage occurs, the ability to trace the events that led to the failure is a key factor in protecting against liabilities. Electrical systems must be maintained properly to avoid poor performance, abnormalities, or outages and failures. If you want to learn more about electrical safety, arc flash solutions, troubleshooting, and maintenance for healthcare applications, contact us or your local Eaton representative to schedule a visit to the Power Systems Experience Center today.